What's up, you guys? Rex here. So, finished my second week of my second semester of medical school, and this week was awesome, where we got to watch one of our professors conduct a brain experiment on another one of our professors live for us via Zoom. So I just want to sort of summarize this experiment because it shows something really cool about how part of our brain can unconsciously learn things. So I'm specifically going to be talking about how our cerebellum can learn how to make error corrections in a repetitive behavior. And so the example here is throwing a ball. So just a little background on the cerebellum. Basically, this is something that does sort of the micromanagement of when we want an action done. And so there's sort of a little bit of interesting stuff of starting with the premotor cortex that sort of will more code like an intention. It doesn't necessarily code, all right, let's contract the biceps. It more codes, all right, reach for an object. And so the exact micromanagement of how that's done has to pass through a lot of different parts of the brain, but a big part of that is the cerebellum that will actually sort of do a lot of error correction. And it is part of sort of that muscle memory, I guess, of how when we think about throwing a ball, we just think, all right, throw the ball. We don't think of all of the little different joint angles involved in throwing the ball. So this experiment we did was about throwing a ball. So it started off, we just did some baseline stuff of we had one of our professors just repeatedly throw balls directly at a target, which was right over a camera, but throwing a ball at a target. And then what we did is we had the professor put on a pair of glasses which made it so it refracted the light by 15 degrees. So when she was looking straight ahead, as far as what she thought was straight ahead looking at the target, her eyes, her actual globes of her eyes in her socket were having to be shifted 15 degrees to the right. And so when she started throwing the ball, just trying to throw it directly at the target, she all of a sudden is throwing the ball way to the right, 15 degrees to the right. And the reason for this is part of the way our cerebellum codes for how to throw a ball is that it has learned, all right, when I throw a ball, I need to do what movements are necessary such that the ball goes in the direction my actual globes of my eyeballs are facing. And so even if I'm focusing on a target straight ahead, if my eyes are shifted over here and I just think throw at the target, I'm going to throw way off to the right and drastically miss my target. But the amazing thing is how plastic, and that meaning how adaptable and malleable these brain circuits are, that it took our professor 20 throws of just still focusing at the same thing, and slowly but surely, subconsciously, her cerebellum made what corrections were necessary to now throw the ball straight on. So even though by the end of this part of the experiment, her globes are still 15 degrees to the right, by focusing straight forward, her cerebellar networks have adapted that they know what straight is and they throw it directly straight. And then the sort of this next stage of the experiment was, all right, let's take the glasses off, now see what happens. And so now she's looking at the target and her eyes are facing directly at the target, which normally before we messed things up with the actual fancy glasses that shift the vision, now she goes to throw straight ahead and instead she's throwing 15 degrees to the left because she has, in the matter of minutes, rewired her cerebellar network to now say, if I'm going to throw at something straight ahead, what I am consciously thinking is straight ahead, I need to throw 15 degrees to the left of wherever the globes in my eyeballs are looking. So she's looking straight ahead, eyeballs going this way, her cerebellum is saying, all right, aim 15 degrees to the left. But thankfully, we just take another couple minutes and throw 50, 20 more balls, something like that, and we can fix the professor's brain so that they are back throwing where their eyes are aiming, which is what we're typically doing. We typically throw at something we're aiming at. And so that was just a really quick experiment I thought I would share. I tried to find real quick on Amazon a pair of these glasses if you want to do this experiment at home. Couldn't find it. Maybe at some point I'll update the description if I find it. And it's really interesting to me that we have this coding in our cerebellum that ties the state of our oculomotor muscles such that we know which direction our center field of view, our fovea, is facing when we're throwing it. And so the professor even though the light was hitting directly in center of her fovea, which she perceived as straightforward, in fact, in order to perceive that, she had to have her globes shifted. And so while her vision was able to adapt where she thought was straightforward, now since her actual eyeballs, the globes of her eyes, are shifted to the right, her cerebellum is measuring responses from within the muscles of her lateral rectus and medial rectus, all of the muscles that are moving her eyeballs, such that it now perceives straightforward is wherever the eyeballs are facing. So that was super cool. And on top of it, it was even more amazing how adaptable our cerebellum is able to learn. And this is something our professor was doing totally subconsciously. It wasn't, she was, all right, we're throwing to the right, I'm going to start just aiming to the left of target and correct better and better like that. They said they were just continuously aiming where they thought the target was, and all of the correction happened subconsciously. It is absolutely amazing, all of the learning we are probably doing every day that we might not even be aware of. So if you have any questions, comments, or concerns, I'd love to hear about them down below. If you want to catch more of these cool tidbits of things I learned in my week of medical school, make sure you subscribe, hit the notification bell. As always, like the video if you liked the video, dislike the video if you disliked the video, and until next time, don't be ordinary, go be great.